Ready to go?
Okay, brilliant. So what we have here is a cross section of the tear film. Okay, so we've got, it feels like it's a magic trick, but obviously it's not. But it is a cross section of the tear film. And I need you to use your imagination. And why I need you to use your imagination is because of this. When I think about the tear film, I struggle to comprehend how thin it is. And I deliberately use the word thin because we talk about the thickness of the tear film being circa 3 to 7 microns, but that's not thick, that's thin. That's less than a tenth of a human hair. So the way that I try and get my head around things is I try to shrink myself down so that I can get inside of that structure. Can you imagine if you could have like virtual reality, you could look around, it would all make so much more sense if we could be like that. A bit like the film Inner Space back in the 1980s where he gets shrunk down and injected, or a bit like Ant-Man, I suppose. But if I can't do that, which is impossible, what can we do to make the tear film bigger? So this is my cross section. So this is my 3 to 7 microns, and we're gonna build the tear film as a result of this. So if we've got the tear film here, the bottom must be our ocular surface. And on the ocular surface, we know it's not smooth. So my tank's not smooth. I've got gravel in here to represent it. Let's think about the microvilli that are doing their lovely fronds, wafting movement across that ocular surface. And we also know that mucins are being released into the tear film, which is kind of the multicolored gravel that we've got down here, all the different mucins that are being put into that tear film. But that would be a 3-layer model, wouldn't it? The mucin layer, and then what would come next? Come on, Thomas, what would be next? Water, the aqueous phase. Now actually, we know it's a mucoaqueous phase. So what we really want is for this to blend into a mucoaqueous phase. So to help us, we need to add some aqueous. So let's put some water into our model. Now, this is showing how the mucins and the aqueous all start to mix together to create that beautiful mucoaqueous phase. So we've got our corneal surface moving up through our mucoaqueous phase, and we're getting up to the top layer, the top element of our tear film. And what you can see, if you look carefully, I just do that as well, it will help, is that we're getting an overflow of our aqueous, mucoaqueous phase, which means it's going into the atmosphere, because this is not our tear film out here. So we've got evaporation. So in order to maintain this situation, what do we need to do? We need that final part of the tear film, which is what? What would you say?
Lipid layer.
Lipid layer. Now that lipid layer creates a thin film of oil across the surface. Now I can't make oil balance on here, but I'm going to use this cling film or food wrap and to illustrate that. Now also what I think is kind of interesting is if this is the 3 to 7 microns, then this is probably not too far away from the scale of what the lipid layer would be across the top. So I'm going to put my lipid layer onto our cross section. And when we do that, we create a situation of homeostatic balance where we have everything in equilibrium. But what you'll start to notice is that this looks like it wants to break because it's bulging. So there's pressure, there's stress being put onto the lipid layer. So if we had a break in the lipid layer, what we would end up having is this mucoaqueous phase evaporating away again, which would cause us to have a problem with the stability of our tears. So when we begin to think about the tear film, if we understand the structure, because we can see it a little bit bigger, and we understand where the problem is, the fragility in its structure, we can also begin to think about the management approach that we might take. So anything that's got an issue or involvement of the lipid layer, we're going to want to think about lipid-containing artificial tears or lubricating eye drops. If we've got a problem with the volume, the bulk, we're going to want to replace more aqueous into that, and that's where we're going to use drops for aqueous deficiency. The really curious thing, just generally, is that if we've got 86% of all dry eye having an evaporative component, so it's some issue with the lipid layer, how come we've got 90+% of all products for aqueous deficient dry eye? So think about what you're prescribing, think about when you're prescribing, and think about how and why it's going to make a difference. And that is just a bit of a silly way of demonstrating the dry ice tear film.